So hey everyone, welcome back to my channel and I hope you guys are doing well. So today we are going to solve a LeetCode weekly contest, and this one is the first question. And I think there is some sort of mistake which is done by the LeetCode that this question is quite difficult as compared to the general LeetCode first question, right? So without wasting any time, let's get started. Count element with at least k greater values. So you are given an integer array nums of length n and integer k. A element is satisfied to be qualified if there exist at least k element in the array that are strictly greater than it. Okay. Return an integer denoting the total number of qualified element in nums. Okay. So let's first understand what the question is. The question is asking us a number is qualified if there exist at least k element in an array which is greater than that particular element. So let's see this example. So if you see here, if we write it here like 1 2 3, so for 1 we see we should have at least k or at least k or greater than equal to k elements which actually greater than 1, right? So if you see 2 and 3 both are greater than 1, so for the if I just do 1, we have two elements which are greater than 1, and for 2 as well we only have, like, for in case of 2 we have one element which is 3, which is actually greater than uh, 2, and it is at least k. Like for in case of 1 we have two elements, and in case of 2 we have one element, right? So they both satisfy the condition. But what about 3? So in case of 3 we do not have any element which is greater than 3, so for 3 it's 0, so it doesn't satisfy our condition and it is not a qualified element right now, right? So the question is quite simple. For every element we just have to find out the number of elements which are greater than that particular element, and they are exactly, like, they are at least appear k times, right? So how to exactly think about this particular problem? Like, what's the first thing which will come to your mind? So when I first thought, or when I first read this particular statement, so what I thought is we just have to find the number of element which are actually greater than my current element, right? So why not do some sorting kind of stuff and then analyze how many are remaining element. Like what I'm trying to say is, like, I know the my array is 3 1 2. Why not just sort the array, and if I'm at ith, like if I'm at 0th index, so I just simply check then how many remaining elements are there, like 2 and 3, because I have sorted an array, and if whatever element is present after the 1 is all are greater than 1, so I just simply count how many elements are remaining after excluding 1 from the array, right? It will give me the number of elements which are actually greater than the current element, and I simply add it to my answer, right? So it works fine for the first test case, but here is the twist. What if the array is like this? So in this case, if we apply the same approach, then our answer become 2. Why? Because for the current element we are checking how many remaining elements are there, because we are considering that the remaining elements are always greater than that, but they are specifically mentioned that we are looking for something which is strictly greater than that particular element, right? So in that case our answer become wrong. So we also need to take care of this particular test case as well. Like our array can contain a duplicate element as well. So in such case, like if the question is simple, like if we have a distinct element, then the first approach is quite easy. We just sort an array, and for the every element we are just counting the rest of the element. If they are greater than or equal to k, then we are simply adding it to our answer, right? But we also got a condition of 555, which is in case of duplicate. So how to handle such case, right? So another thing which came to my mind is that why not just figure out the unique elements, and on those unique elements we will do the same thing which we are doing here, is right? Because the only problem which we are facing here is because of the duplicate elements, right? Otherwise our question become quite easy, right? So in order to do that, what I have done is uh, like few, because removing duplicate element doesn't mean I am removing the count, right? Make sure, like for example, let's say uh, another test case is 1 1 10 10 and 10, right? So it has duplicate elements. After removing duplicate elements, it become 1 and 10. So I'm counting the same stuff, like I'm performing the operation on this particular array and checking if how many elements are left which are actually greater than my current element, and their count is greater than k, and let's say k is 2. So do you think it satisfy the condition? Even in original array we have elements, but due to making some element distinct, we are lost these elements, and we are not now we are not able to satisfy our condition, and we are not able to pass. uh, Due to that reason our answer becomes 0. So we also need to take care of that particular test case as well. So what we can do is we simply store that the elements inside the map, so that we also get the number of count of each elements. For example, let's say instead of this we have like 11 and 12, right? And due to when we remove duplicate, our array become, right? Then now we are counting for 1, then it is actually our qualified element, because we have a 3 element which are actually greater than k, and our k is 2, so it is fine, we got our answer. But you see, we have a 2 1, but due to removing or due to making our array distinct, we lost that particular element as well. So we also need some ways to actually like to calculate the answer of that element as well, right? So for that we can create a map. How can I do? Like 1 appear 2 times, 10 appear 1 times, 11 1, and 12 is 1. Let's put it little above, right? So what happened is, right now if I'm performing operation on this particular array, right? So for the one I got to know that it is a qualified, then I simply check inside the map how many ones I have. That number of elements is qualified for my current condition, right? So I will add that particular element in my answer, not just one. So this is the whole idea behind of this particular problem, right? So what's exactly we have to do? First, make our array element to distinct, store their frequency, like first store their frequencies inside a map, so that will help us to find our answer more accurately. Second, make all the element distinct. Third, traverse on the elements uh, and one by one, and then check the condition of the same thing, like make sure to store the element in sorted order, because that will help you to check how many elements are there which are actually greater than our current element, right? So that will help you a lot. And after that we just simply count how many like elements are there whose are actually greater than our current element. But make sure one more thing: what uh, if there are more elements, like 10 occurs 10 occur 2 times, then we should also make sure of one more condition about that. So let's see that condition in the code as well. So I just show you the code where it make more sense to explain you in a better way. So what I have done, as I mentioned, I have created a tree map, because I don't have to like sort an array, because it will give me the keys in a sorted order. That's why I created it. And I have created an array list to store the distinct element, right? And here I am just putting the element inside the array and storing the distinct elements inside my answer key, uh, answer array list. Now what I am doing is, I have taken an answer as a size, like I am traversing on the distinct elements, its elements, right? And I'm running a loop from one towards the like size of the array list, and for every step what I'm doing, uh, getting the frequency of current element, as I already said, like explain you about this particular thing, like getting a frequency of the current element, right? uh, and after that I'm just checking, like what I am doing here is, I know the total number of elements I have is n, and right now I'm removing my current element frequency, because it is not going to contribute to the answer, because it helps us to uh, make our answers for how many elements we have right now, right? So we are simply removing the frequency of that particular element, which will gives us the number of count of the element which are actually greater than the number of, like, greater than the value of current element. For example, which I have told you, like 10 is 2. Like what if, like, our array is like 1 uh, 1 1 10 and 10, right? And you have just the current, the size of n is 4, right? And we have make it a distinct, so now we have an array of this where 1 is occurring 2 times and 10 is also occurring 2 times, right? I came here for 1. I'm checking how many elements are there which is actually greater than the current element. If we just look towards this, we just only got one element and our k is 2. So don't you think we are also missing one more condition? Like, we are not initially we have 2 10, but due to when we make it as a like distinct, we lost our one count of 1. So we utilize the frequency of the particular element through the hash map, right? So we have stored that value somewhere. So total number of elements we have 4, right? Now we are currently calculating for the current element, so we remove the current element frequency from our total number of frequency. What happened? Like, we have a n is 4, we are subtracting 2, then we got 2, which will actually the number of element uh, we rest when we exclude our current element, right? And with this we are simply able to calculate how many elements are there which actually are greater than the current element, right? Once we done with the with our this element, then we simply decrement the value of n to uh, is equal to n minus frequency of current element, right? Because the current element is not going to contribute to our answer for the further elements, right? So we are shrinking our size of the n, because we have done with this uh, these elements, like the first two elements, these two elements, right? But they are not going to contribute for our future answer, so we are removing it, so that for next element we are able to calculate how many elements are left, that will help us to calculate this particular answer, right? So this is the idea behind of this particular thing. When we got size, we simply check if it's greater than. If it is, then we are simply adding the number of frequency which we get from the current element, and we are subtracting its frequency, so that, because it is not going to contribute for our future answers, right? So that's the main idea behind this particular problem. So talking about the time complexity, it's going to be like O of n for like running this particular loop, and similar for O of n either here as well. And it is also like, it's overall, like, you can say O of n. Talking about space complexity, it is O of n for hash map, plus it is O of number of distinct element. Let's say all elements are distinct, so it's leads O of n. So overall the space is n, O of n, and the time is also O of n. So this is all about the problem. Let me just run it once again. You see, we are able to pass all the test cases by following this particular method. So I hope you like the video. If you like the video, please do comment and do like the video. And if you understand the approach, let me know in the comment section, so that I got to know about how you well understood about this problem. And if you have any suggestion regarding the explanation of mine, so do let me know in the comment section. And this is it for this video, and bye bye, take care.